Hello everyone. In this work example, we're given a valve handle, and we've got two sets of forces. So we've got forces on the left and forces on the right. I'm going to call this situation A and situation B respectively. We want to determine if these two sets of forces and moments are statically equivalent to one another. So to do that, we need to basically sum up all the forces in the x direction, sum up all the forces in the y direction, and sum up all the moments. If the sum of all of those things is equivalent in all three cases, then we know that they are statically equivalent. If any of those do not match, we know that it is not equivalent. So for this, I'm going to kind of like split up my work. Over here on the right, I've got A. And for that, I'm going to sum up the forces in the x. And that's basically going to be 80 to the right, 80 to the left, so 80 minus 80, which is equal to 0. All right, so in the y direction, so sum of forces in the y, I'm going to have 50 going down and 30 going down, so negative 50 minus 30 is equal to negative 80 overall. So rather than boxing these, I should probably underline them. We're going to compare. And then finally, the sum of moments. I'm going to do about the center point. So the center point here, I'm going to call C, is going to be, well, I have just a straight moment in there first. So counterclockwise, that's going to be positive. So 30 plus, or sorry, let's go 30 minus, and then we're going to do the top one, so 80 force times distance. The distance is going to be 0.35 meters, half of our 70 centimeter diameter. So, and then that's the moment of the top force. Moment of the bottom force is also going to be minus 80 times 0.35 for this bottom force here. And then I'm going to do the 50 and 30. So if I do the 50 first, so plus, this one calls a clockwise or counterclockwise moment, so this is a positive moment here. 50 times 0.35, all of these are 0.35 out from the middle. And then finally the 30 Newton force, that's going to be a negative moment because it's going to be clockwise, 30 times 0.35. Right, and so this is going to be equal to negative 19 Newton meters. All right, so I've got sum of forces in the x, sum of forces in the y, and sum of moments. Let's check it on B. So for B, sum of forces in the x, it's just the 60. So 60, and so that's the only one, so this is 60. So we can already see actually these are not equivalent because sum of forces in the x, 0 and 60 are not the same, so these are not statically equivalent. So I could stop at this point if I wanted to. I'm going to follow through and check the other pieces as well. But at this point I do know if any of these pieces don't match and forces in the x don't match, they are not statically equivalent. But if I go ahead and check the y direction, so sum of forces in the y, it's going to be positive 80, negative 80. So 80 minus 80. It's going to equal to 0. So this also doesn't match. So I've got negative 80 sum of forces in the y for situation A, and sum of forces in the y for situation B is 0. So it's doubly not statically equivalent here. And then finally, I'll take the moments about C. So this, I've got 16 Newton meters. So 16. And then I need to, if I do my 80 Newton force, I'm going to do my 280 Newton forces first. So this is going to be negative 80 times 0.35, negative 80 times 0.35. I have two of those. And then I've got my 60 Newton force. That would cause a counterclockwise moment, so that was actually positive. So plus 60, 10.35. Add all that together, I would get negative 19 Newton meters. All right, so the moments do match, but because the sum of forces in the x and the sum of forces in the y don't match, these systems are not statically equivalent. All right, so that is all I have for this work example. Thank you for watching, and I hope to see you again.